Oh, thank you. Thank you for this amazing talk. I feel like I filled half of my notebook with notes. So I have because you touched on a series of topics that I find extremely interesting, starting from the idea of accountability, and not so much. That is, of course, important because of questions like, for instance, explainable AI and how we can, make sure that the decisions, that the actions that are done by a neural network can be trusted, right? Trusted at a fundamentally humane and subjective level, the same way that you trust, I don't know, a doctor or a judge or any person of authority. And once you give authority to an AI, you need ways of trusting it. So you need explanations. And those explanations, as you very well pointed, cannot really come from understanding the system, because the system is not telling you anything about the nature of the decisions. Rather, it's the interaction between the system and the data and its users, and sometimes that will somehow make that decision come. But I also find this question, and so do you, really important in the context of artistic creation with AI systems, and about the usage that artists do of computational technology and AI in particular. I particularly like how you raise the question of the selection process as part of as an artistic process that almost brings the artist to the position of the curator, the artist that works not with a tool, but with something that is more than a tool, something that is treated by the artist as having effectively some creative potential. Not something that you can compare to the creative potential of a human, for obvious reasons, but something that, because of its unpredictability, or what Stephen Wolfram talks about, the irreducibility of computational processes, the fundamental unpredictability of computational processes. And because of that, as part of artistic practice, very often it's incredibly interesting to work with tools that are deeply unpredictable, and that at some point you can develop an intuition for what their outputs will be, but you can't really predict them. So you start working with them a bit in similar ways as you work with other humans, because you kind of understand, you have this intuition for what the output of a human, I don't know, visual artist or musician can be, but you can't really predict it too well. And this is something that really interests me. And what I found mostly, or perhaps my main takeaway point from this, is how, computation in that sense of Church and Turing is not universal. And at the same time, because computation, especially through, von Neumann machines, is an extremely good simulator. It can simulate these systems that are universal, right? That are intuitive, that live off feedback and interaction, and that become subjective. There's actually I can't remember it too precisely, but Friedrich Hitler had this argument about computers and software being subjective, or starting being subjective, at the point where you can, program an if statement, because you're giving the decision to the computer. As simple as that if statement is, then you're, delivering that decision to the machine, and then you're, increasing its subjectivity, even if by almost nothing. But enough of me. We have several questions from the audience, and I will maybe start with the first two from Daniel Abramovich. The first is a comment about how David Mindell has a great book on feedback technologies for gun directors. And there are also some papers by him that kind of, prove your point that Wiener came along after that. But then he reminds us of Douglas Adams is, well, in Dirk Gently's Holistic Detective Agency by Douglas Adams, he introduces a program that he calls Reason. And it's a program where you enter an answer and you enter some relevant facts, and it strings together a rational way to get from the fact to the decision you want. This is very Douglas Adams. And is something like this that we need to achieve explainable AI? A machine that can, do post-facto explanations of whatever it decided to do?
Well, what I find scary is that I believe that it is possible to make such a machine that will give us post-facto explanations for any decision. And the question then becomes, well, how is that useful? Right? I mean, if you can give a rational explanation for any decision, what good is that rational explanation? Right? And, exactly. But I mean, humans do this all the time. The news reports on the stock market, right? Mm-hmm. Stock market went up today for some reason. 2 weeks later, stock market went down today. Same reason. Mm-hmm. Mm-hmm. Okay. You see that?
Maybe, yeah. But maybe bringing these more to the field of psychology, and I'm not a psychologist. Maybe it's the actual process of doing that, of rationalizing the decisions, but then entering into a feedback loop with oneself, like discussing our decisions in the light of our rationalization of decisions. Isn't that a process that can fine-tune those decisions, maybe?
Well, so I think the computer. Yeah, I think that one part of the value proposition that might emerge from this is exposing biases, right? So if the machine gives you a post facto explanation that has among its rules of logic rules that we would find socially unacceptable, right? They may be perfectly logical, but they may not be socially acceptable. Then we can use that fact that there is a way, at least, to have reached this conclusion through biases that we do not wish to accept at a social level. Okay, so that fact, I think, could be useful. And that could, for example, expose biases in the training data sets that are used for training AIs. So I think that's what the community is trying to accomplish with this explainable AI. And if they do successfully accomplish that, I think it will be a significant step forward, because we can learn about the biases. The biases arise from the data sets, which means, and the data sets are generated by human activity. And so it'll expose human biases, if we end up with that. But that doesn't mean that we get unbiased AIs. Actually, making the AIs unbiased is going to be an even bigger challenge.
Yeah, and we have a question by Pinto in Pinto here that, this previous reply almost started replying it, but I will go at it nevertheless. Actually, two questions. The first is that in regard of the example you gave about a man being defeated by a chess game or a chess machine, how do you think this machine could later teach back the loser or the human on how to win? Is there a process to actually turn these into learning experiences? And
yeah, I have no doubt that there is. I'm not a very serious chess player nor a Go player, but I am a pretty serious computer programmer. And I can tell you that the machine teaches me. Absolutely, without doubt. And the technology supporting computer programming is getting more and more integration of AI in it. Mm-hmm. And the programmers are learning from the machine. So yeah, there is this feedback process right there. And in fact, I talk about this feedback process in quite a bit of depth in my Coevolution book, where the programmers are writing programs that are then teaching the programmers to write better programs. And so it's a feedback system.
Yeah. Yeah. And that's what Kasparov defends, right?
That's what Kasparov defends. He says that it actually enriches the game. And I'll take his word for that, but I can tell you from firsthand experience that the experience of programming computers is vastly enriched by this feedback loop.
Okay, and this is still a question from Pinto in Pinto. He asks if you could tell him a little bit more about the title of the book and why did you come to this, the Coevolution. I wonder if it's related to, I don't know, what Kevin Kelly calls the technium or Manuel de Landa calls the machinic phylum. But
yes, it's very much related to that. And in fact, Kevin Kelly is one of my back cover endorsers, and I talk quite a bit about his work in the book. In fact, my original working title was Living Digital Beings. And it was looking at the question of in what sense are the machines actually a living part of our ecosystem? The publisher, MIT Press, hated that title, and so they talked me out of it. But the Coevolution title is addressing one of the key themes of the book, which is that many people naively think that technology is the result of top-down intelligent design by humans. Yeah. And my claim in the book is that it is not. Okay, that humans obviously play a big role in technology development, but the development is much more Darwinian than we realize. And individual humans have much less control over it than they think. So this feedback loop that I was just talking about of the computer teaching the programmer to write programs that then teach the programmer how to write programs, that's not top-down intelligent design. Okay, it's also not deductive reasoning. It's a feedback system. It's an interactive system.
Yeah, and going back to a question by Daniel Abramovich, he says that, well, he congratulates you on the talk, and then he says that it seems that feedback principles are treated like the scare quotes bastard at the family reunion in many discussions of AI, ML, and DNN. And the question is whether is this accurate, and if so, how can this be changed?
Well, I think that one of the pitfalls is that people tend to talk about the technology of tomorrow in the culture of today. But we're not going to have that. That will never happen. The technology of tomorrow will be in the culture of tomorrow. Right? And one of my claims in the book is that the culture co-evolves with the technology. And so that makes it much less predictable what's going to happen. But there are Darwinian forces that I think are favorable, right? I mean, I think that, evolution is itself a feedback system, and in some ways a self-correcting feedback system, right? When you get pathological behaviors, the tendency for things that propagate to survive has a side effect of suppressing those pathological behaviors, right?
Yeah.
So that doesn't mean that the pathological behaviors won't occur. In fact, I think they inevitably will occur. But my claim is that we will need to adapt, and my hope is that our adaptations will deal with the adaptations of the machines in ways that are beneficial to humans. That's a hope. Okay.
Manuel Firmino is asking that since humans make decisions not only with rationality but also with emotions, do you think that we need a deeper knowledge of emotions in our brain to better understand creativity made by artificial intelligence? Or do we need, and this is me following on this question, or do we need to have something of an analog for emotions by artificial systems?
Yeah, that's a challenging question. I think that in my book, I talk about this concept that was first introduced way back by Plato in Timaeus, who essentially said that if you can understand the processes that lead to a particular behavior, if there's a logical explanation for them, then you can't hold the person accountable for that behavior. Okay, that's one of the key ideas in Timaeus. So, for example, if there's a explainable brain process that leads to a mental illness that causes someone to behave in a certain way, then, according to this principle, you can't hold that person responsible for that behavior. If you take that concept too far, that means that the more we understand about the brain, the less we're going to be able to hold humans accountable for their behaviors, which I think is not a useful conclusion, right? I mean, it would suggest we should stop studying the brain and not try to understand emotions, right? But to me, that's just absolutely not a useful conclusion. I think the more we understand about the processes, the better off we're going to be.
Yeah, this follows up with a question that Luis Spiritu Santo sent, because he's interested in the meaning, or in what you mean by machine, because you say that Turing machines are limited, as Turing himself proved that in 1936 with his original paper. But then the brain can do more while also being a machine. So doesn't this imply two different meanings of machine?
Well, I think that it does, actually. I mean, the word machine can be used for any physical process, right? There are many people who actually believe that all physical processes are actually computations. There's this whole cult that we are all living in a computer simulation. I actually, in Plato and the Nerd, the first of these two books, I show that hypothesis fundamentally cannot be tested by experiment. Okay, and as a consequence, it can only be taken on faith. Mm-hmm. And I also show that it actually leads to a much more complicated explanation of the world than much simpler explanations that don't rely on computation as the fundamental mechanism. Okay, so it's not a scientific hypothesis. It can only be taken on faith, and it's much more complex and difficult to work with than a more direct explanation. So, okay, if you want to believe that faith, that everything is computation, go ahead, but you've chosen a rather more Baroque theory than more direct explanations of how the physical world actually works. So the fact that it's untestable by hypothesis actually follows from a mathematical result due to Claude Shannon, and also from this incompleteness of determinism. So it's untestable because of the fact that noiseless measurements are impossible because of the incompleteness of determinism, and that noisy measurements can only reveal a finite number of bits of information because of Shannon's channel capacity theorem. And as a consequence, every experiment that you can do only gives you a finite number of bits of information about the physical world. And no such experiment, therefore, can disprove a hypothesis that the physical world is just a computation. Mm-hmm. So I make that argument. It's a fairly technical argument. That's in the Plato and the Nerd book. But the bottom line is this: that this dataism is a faith. that everything is computation is actually a faith, not a scientific principle. And I argue that it's not really a defensible faith.
Mm-hmm. Now, I'm mindful of your time, but if I can, I still have two more questions from Luis Almeida that are somewhat related. The first is whether autonomous systems will have to go through a learning period to develop semantic concepts for safe operation. And the second is, again, on autonomous systems, how to combine rigid lower layers following critical systems principles with higher layers with desirable plasticity and continuous adaptation for improved resilience.
Hi, Luis. Nice. I'm glad you're here. I know Luis. Those are fantastic questions, and I think that the short answer to this is that I'm actually very encouraged by efforts that are going on in the AI community right now to combine the deep neural network revolution with good old-fashioned AI. In other words, what people are trying to do right now is actually pull the best of these two worlds together. The quick intuitive decision of Kahneman's system 1 together with the deductive logic that computers are so good at, right? When you put these two things together, I think you end up with much more powerful systems than when you just pick one or the other. And so I think that is in fact what we're seeing in applications like autonomous vehicles, where they're not just turning everything over to a blind neural network that makes all the decisions. They're overlaying on top of that logical deductions that are used, for example, to provide safety envelopes around behaviors. There are certain behaviors that you want to constrain this behavior. You don't want to let the AI do whatever it comes up with, right? And those constraints take the form more of these deductive logic decision making. And so that combination, I think, is more powerful than either of the two technologies by itself. And for the first part of the question, yes, I think the machines will have to integrate learning tremendously. Now, one advantage that the machines have that humans don't have is that what they learn is transportable to other machines. I've been a teacher for 40 years, and I know from firsthand experience that conveying information, conveying learning from one brain to another is unbelievably difficult. It's slow, it's inaccurate, it's, humans are sort of, have to start from scratch and learn everything on their own. Machines have an advantage that they can actually benefit from each other's learning. And in the context of autonomous vehicles, that can be enormously beneficial because, most of us, our driving experience is very limited. There's many, many scenarios on the road that we have never experienced and will never experience, but some human has experienced them. Well, in the context of AIs, if any AI experiences, all of the AIs can benefit from that.
Yeah. So this was, again, I think we now need to close because we've been running for a while. So this was an excellent talk and a pretty good discussion too. Thank you so much for this, Professor Lee. This was, Firmino is here. Hi. Yes, so I'm going to give this away to you again so that you can close this first cycle of talks. Yeah. Once again, it was a pleasure and an honor to be here.
Well, thank you very much for the invitation. It's really much appreciated. I'm very enthused about this talk series.
Yes, thank you very much, Professor Edward Lee. This was outstanding and a fantastic and inspiring talk. Yes, it's wonderful to finish this year with you. And also thank you, Miguel Carvalhais, for your moderation of this event. Thank you all for your participation on these 5th Creativity Talks. And honestly, we look forward to see you soon in our next talk on 2022. An excellent night to you all and a good Christmas. Okay, please stay safe and be creative.